Hello, and welcome to this video about how to create a data warehouse in the big data space. So my name is Albert Garcia, and I'm going to explain how I built these solutions using Data Vault 2.0 and some other frameworks in Python back in Japan and something in Australia. And right now I'm living in Switzerland and implementing the same solution again. So let's move on. First, I want to explain the agenda. So we are going to be doing like an overall architecture of the data warehouse in this big data space. I'm going to explain all the artifacts that I used to use. And then we're going to jump into the problems when creating a data warehouse in the big data. So why there's not so many people using big data data warehouses nowadays. And I'm going to explain what I think is the reason and how to actually solve this. So the big data warehouse is composed on three steps or three layers. One is the ingestion layer that has to be automated, the enterprise layer, that's the data warehouse itself, and then the data access layer, how to consume the data easily. Then we are going to be explaining about the security that you can put in place very easily, and we are going to just recap a data journey about what we accomplish doing these solutions and how the company can benefit from it, and also some estimates and cost of how to set up this. Looks like it's gonna take like a really big project for many people, but it's not so big anyways. So let me explain with detail. First, we are gonna show this full architecture of the data warehouse living in the big data space. Okay, so here you can see the full architecture. There is like three parts, as I mentioned before. One is from the source to Hadoop or to Kafka. This is real-time and batch, and yes, this has to be automated because it's raw data, and raw data is not it's a no-brainer actually. It should be there for free, let's say. So once you automate and you bring all the possible data in your ingestion layer, okay, then you can start summarizing, applying business logic, and making some sense out of this data with your enterprise layer. That's where you summarize. You have the enterprise and maybe the presentation layer where you have the marks to make it more easier to get the information out of this data. Then you have the data virtualization and exposure layer, this data access layer, that I prefer to use Presto, for example. It's a good technology for that, but the market is full of options, and you are free to just choose whatever. But this is an example of how to do it, and I want to explain it. So, okay. Then, first of all, we have to ask, why not so many companies have their data warehouse in the big data space yet? Why not? I mean, are they afraid of something? They are really old school and they really need their data in a Teradata database or an Oracle database, which is really expensive to maintain, versus the Hadoop space, for example, where there's no license almost cost, or the hardware is much cheaper. So why not to do this logical move? This, and per my understanding, these three problems: the ingestion, the transformation, and the data exposure. So let's jump into the ingestion first, okay? So how to get the data into the stage version or Hive tables of your Hadoop? It's something that usually takes a lot of time and a lot of effort for many companies and many teams. And that should not be the case, because we are doing apples to apples. We are talking about just raw data. We are not doing any magic there. We are not doing any business rules, any over engineering. It's just bringing the raw data, okay? Then you don't want to do full snapshots, or you don't want to create some extra logic that will make it difficult to query this data. So just, just need to maybe historize it and put it in a shape that will be easier for any data modeler or anyone to use this raw data. Talking about raw. So okay, let's have a look. There are these problems. First, it's always a manual work, and it's costing a lot of problems with ETLs and lifecycle management, etc. So it costs money, okay, just to bring the raw data. That's first thing. Then if these sources are actually acquiring more data, suddenly they have more tables or have more columns in all the tables, and the source is actually changing, then you have to really be there like reactive rather than proactive, because somebody has to notice that. Maybe an email is sent, maybe somebody just noticed that there's a new table available, and then you work on it again manually. So that's really not good. Then if the source is changing, then you have to fix your ETL again manually, and maybe some errors. Hopefully they will tell you with time that the source is changing, but this is not happening all the time or never. So therefore, that's another problem, okay? And finally, maybe you have Kafka, or you can actually get your HDFS files with all the information, a bulk of all these databases back in MySQL, SQL Server, Teradata, etc. But this is maybe in a format that is not really doesn't help to use. I mean, it's maybe a full snapshot every single day, and then if you want to have history out of this snapshot, then you have to query exactly which day, and you have to maybe bring it to a Hive table to make it more easier to consume. So it's taking a lot of time and it's really slow. So therefore, that's another big problem. Solution for all this is just basically create a framework in Python with some database which will contain just the access to these sources databases, like a server, IP, port, user, and password. That's about it. And then this Python will connect every day to these servers, will extract all the DDL, all the metadata, put it into some Hive or MySQL, whatever database. And then once you know already the metadata, you know all the tables available in the source, then you can start doing a bulk of these tables into HDFS directly. It's just a simple bulk. It's a CSV file. So it's really also not really a big deal there. But still, you have to do it. Then once you have your HDFS file, you still need to bring it into a Hive format, let's say. So therefore, you need to stage it in Hive. This is something that the framework can do also automatically. Then you can actually do history on this Hive table. Maybe you have a snapshot, a full snapshot every single day, but you don't want to keep 365 times the same database in your Hadoop system. You just want one database with all the changes and all the history there. So this is also possible to do. Just need to specify the primary key of each table, and that's it. This maybe is actually provided by the source. Maybe some sources doesn't have this information, like Teradata. It's really difficult to find this primary key because they are using index. But anyways, you just manually fix it, or maybe the source, SQL Server, MySQL, etc., will provide you with a primary key, and therefore with that you can start creating history. Okay, and this will be also do it dynamically, like automatically. And then you can expose all this data through a user interface and then show your data catalog about all the data that you have available, okay, as of today. Next day, okay, you will actually connect to the same server, get the metadata again, and then find out that there's an extra table, there's an extra column somewhere. Then the Python framework will react to that and alter the table and bring the new column into the ETL, which is again dynamically created every single day, or we'll just get this extra table around and bring it to the stage version, then history stage, something more persistent, and then again show it in the data catalog. So it will be proactive rather than reactive. No human needs to be there doing anything, and therefore you are going to have all the possible data available for you to start modeling and start getting the value out of it. That's the first thing, that ingestion layer. So from the source to a historized Hive table without human interaction, that's the goal here. Okay. If your company has already something like that, or doesn't care about the sources so much because all the possible sources are already in Hive and already, even if it's a manual work, but already there, then okay, then let's move to the next step, okay, which is going to be the transformation and integration. That's the data warehouse. That's where you summarize the data and you do this integration. So what that means, here I expose it into two different ways. One is the ETL that must be automated. Okay, that's something that I will show how, but you can automate the ETL and even the mark creation. And another one is to choose the right modeling technique to make it scalable and very flexible and modular, and that's actually just Data Vault, I can tell you right now. And I can explain a case that happened to me, and this is, this you can use it anywhere else. So let's start with a manual work, okay, that needs to be automated, and this is something like that. So automation is really, really, really important, okay? So you really need to get this done, otherwise it's going to be an overkill, because you are actually investing too much time into something that a machine can do for you. We are talking about just the typical ETL, okay? So not the modeling. Modeling is what the modeler has to do, the developer has to do, the solution architect has to also have a look, but not about the ETL. The ETL is something really simple and really dummy, actually, okay? As long as you follow the rules, nothing will break. So let's see what I did in the past. So with the same Python framework, Python is really easy to use, so it's something that I really like it. First, you have your ingestion layer, your raw layer. It's already there, okay, granted. Okay, it's already ready to consume the data. Then you create with Data Vault 2.0 views, following some conventions, following some rules that I also had in my own solution. But as long as you follow these rules, then you just create the views, and then the Python framework will read the views, will get the metadata, and will start creating these tables in a persistent way. Okay, so you have a view of a satellite, or a view of a link satellite, or a link, etc. And with this information, I can create the persistent satellite, the persistent link, or link satellite, create the history, do a delta load, check if there is any problem with the data, like if there's duplicates or something like that. So you can do so many things there, okay? And everything will be automatically done. The only thing that the human or somebody in your company has to do is just model your data, okay? Even when you are already having everything ready for, or everything already loaded into Data Vault, then you can actually even create two types of marks dynamically, so automatically, sorry. One is the star snowflake schema. This is something easy to do from Data Vault schemas. And something that I call relationship-less marks, or flatten out all the objects in Data Vault. All the objects means like a hub with few satellites will become one long table, okay? It will be like kind of the normalized. If you have a link with few satellites and few hubs and few satellites, then we bring everything together into one long table, okay? So it's very heavy, but at the same time, it's easy to consume for maybe machine learning, or for, I don't know, for business users even, because they want to have, they don't want to worry about links and about connections and relationships. So this is also something that can be auto-generated in a shape of a view that will perform very poorly. It's really slow. Okay, this is something I can tell you. I'm not gonna lie here, but then you just materialize these views once a day, drop and create, get this view, which is every day regenerated based on your Data Vault model, and there you go. Today I have a fact table with 5 dimensions. Tomorrow I have 2 fact tables, and the previous fact table, maybe the old one, has a 6 dimensions instead of 5, and maybe one of these dimensions are growing in number of attributes. So everything will be kind of, reshape every single day. And that's amazing. Then that access layer is a Presto or anything else that you put on top to consume the data easily. Okay. This framework will automate the creation of the data vault and even the creation of marts. Not all the marts. It won't solve every single problem in your company forever, but it will help a lot. Okay, this I can tell you. And the data vault, EDW, the enterprise data warehouse using data vault, will be there and will be error free. Like if you follow the rules, nothing will break for sure. So okay, then let's move to why data vault is so scalable and how this looks like actually in a real world case. So I was actually working in a company that was having so many companies under their enterprise. Like they were buying companies about I don't know, banks, travel, or I don't know, renting, e-commerce, many of them. Okay, and they wanted to put all these companies together into one big data warehouse. How I did it? Very simple. Just create a hub for the customer, for example, then a hub for, because every company, regardless of their business, they have customers. Then each, so the customers, they share common attributes like name, surname, gender, date of birth, nationality. All this is always there. Okay, no matter what your company is doing. If it's a football team, or if it's a radio, or if it's you have customers maybe, and then you charge them, and they are anyways physical persons, but then you have specific attributes for each of these business. So you have travel, maybe you have some, I don't know, points for miles, or preferred transportation, or I don't know, many things. Bank, maybe salary information, deposit plans, or something relevant for the bank, etc. Okay. And then something that also helps a lot using data vault is that you can do agile, truly agile. That means that from the sprint 1 or sprint 2, you can start already putting this data warehouse in production, and you don't have to worry about the full picture, this big design up front that you used to do in the 3NF, in the enterprise warehouse, or in the dimensional modeling, where you really need the full picture before you start. And then whenever you finish, you realize that it's actually everything wrong. So here, no, here you can start very small, and you can start already having value. Okay, so let's say sprint 1, you just create the customer and order and some common attributes, and you link them. Okay, maybe you don't have access to the ERP or CRM, so it's very basic what you have there, but you still can already do some counts and start having some fun there. Sprint 2, maybe you get some specific attributes for mobile, business, for the e-commerce, travel. Sprint 3, maybe you have an order line on top of the order and some attributes on the order. Sprint 4, maybe you add the item. Sprint, I don't know, this is a scale agile, safe. So let's say that you're in the PI2, no, product increment 2. Sprint 1, then again, you bring more satellites around, you bring another entity like product, then product e-commerce, product common, etc. Okay. So this is one example that from each sprint, your data warehouse can grow and can be used already in production. Okay. So this is really, really good to actually prove that this is the way to go. So you can realize very early, in the process, that you are doing the right thing or the wrong thing. Sorry. So, okay, then let's move to the last part, data virtualization and exposure. So here I'm gonna show again more or less the same diagram as I showed before. Like you have all your Hive tables with the history, all in with current views, with history views on top, with the start and end date. You have the audit. Everything's insert only, by the way. No updates in Hadoop, please. Okay. So in the history stage and in data vault, only insert. Once you have you insert all this history, even though the primary key is there 3 or 4 times, and the only thing changing is the load date time, for example, the timestamp, you can start creating the end timestamp, the end date of your record in a dynamic way. Okay, it's going to be a view that the framework creates for you, and it will show the start and end date, the start and end date, the start, no end date, which is 9999, doomsday. Okay, this is very easy to do. You create your raw data vault, your business data vault, your error data vault, anything that you need. Then you move to the presentation layer. It will auto-generate star schemas, snowflake schemas, flatten marks. You can start copying data across some other high-performance engines like Teradata or Oracle or SQL Server. So if you use on top this, if you use on top this Presto layer, nobody will actually know if the table is coming from Hive or from Teradata or from both. You know, you can actually even do a left join Teradata, left join Hive, and from SQL or MySQL, etc. So it's really like a black box for the customer. So the customer, the only thing that will do is actually consume the Presto layer, the one entry point, one output point, sorry. So this is really powerful also. It's really nice, really clean, really neat. So you have to try to do something like that because it works really well. Then last part, security. So with the GDPR in place and all these new regulations, I think it's really important to have it present from the very beginning. Okay, so let's see. This is one example of a framework that you can create on top, again with Python, and very simple. So basically, you have maybe confidentiality from level 1 to 5, 5 being the highest. You just need maybe some table somewhere in Hive or in MySQL or whatever, and you can actually specify security levels for each column of each table. You can even put some mask flag or blacklist. Blacklist means this won't go to the data warehouse ever. Credit card number, for example, is not there for sure. ABS number, which is kind of ID, identifies very precisely who is this guy. Could be actually mask, which is just putting an MD5 on top, and then the rest is just the levels that you are going to be able to get this information. So you have one physical table in the highest ranking, like a C5, with everything in there, everything. Okay. Then you create another schema where people have access only to the C4 data. Okay, they don't have access to the C5, but they have to the C4 schema. And this C4 schema is going to be just a drop and create view pointing to the C5 and maybe doing the hash on top of the AVS number and maybe avoiding some columns here. Then C3 is going to be the same. Another schema, people will have access only to the C3, where you will see all the columns from C1, C2, and C3, but not the C4 or 5, okay? And again, it's a view that will be dropped and create every single day or every hour, whatever you like, and therefore it will show just information up to the level that you are pointing there. C2, for example, is going to be just maybe address, zip, and city, so it's already compliant with the PIIs. Really, you cannot identify anyone just with this, or maybe just C1, which is really zip and city, is like postal code and city is something that it's again impossible to identify anyone here. And this is very easy to do. We did it. We actually put it in at the beginning in Hive, then in Presto, but at the end this is an idea. You can improve it. You can do many more things, but remember always that over engineering is also something that people has to be really careful, because as for me, the difficult part is to make it easy. So you should try to make things simple, because otherwise, even though you create a lot of documentation and you explain it so many times, and people will come, new people will come, old people will go, and then nobody knows what's that, and nobody wants to really understand it because it's difficult, and therefore, boom, it's all a disaster. So if you keep it simple, it will help to make it longer, let's say. So to live longer. Okay. So okay, this is more or less the idea. And so what we get at the end of the day. So let's try to recap all this into a data journey that I want to expose. What are you gonna be enjoying at the end of the day here? So basically, you are going to have every day your raw data is automatically discovered, transferred, historized in a simple and easy way to access Hive or Presto with tables and views. Okay, so it's really, really important that the raw data is already there and it's kind of for granted. It's for free. You don't have to spend a lot of effort. This is an apples to apples mechanism. You don't need a human thinking and manually clicking things around just to get raw data. Raw data should be there, for free. We are in 2019, almost 2020. We shouldn't be spending more time in just bringing data manually. So this is one thing. Then data modelers will need to create views to fit their data warehouse. Means that you don't have to do ELT or ETL. You don't have to use Power Center or these integration services or these tools anymore. Everything will be handled by the framework, Python framework. You can create it in maybe 1, 2 weeks, 3 weeks, and that's it. You don't have to worry about ETL anymore. Okay, this is a very important part. The data warehouse grows in number of objects, and it will be automatically creating 2 different virtual marts, dimensional and flattened structures. This is difficult to do. I did it, and I would say you should try, or maybe you can ask me, but it's possible. That's the point. It's possible, but I'm not saying it's easy. Okay, just keep it in mind. So these virtual marts are really slow, as I said, and they are in Hive. It's like a composed of connections. Data Vault is already having so many different relationships, and then on top we are creating these virtual pit tables, and we are doing so many things. Therefore, they're really slow, but you just materialize these views every single day into a table. You put a Loom filter, maybe in Hive or whatever, and even with tests, Hive tests, is gonna work just really well. Security framework, together with the data vault capabilities, will be really easy to use and to the GDPR compliant. So you can actually put this information of these satellites that are really, really critical for security in a very secure server, or you can do anything that you consider there. Hot and cold strategy. So okay, here is something that I really need to explain, but maybe in another video. So Presto, for example, can actually get all your queries. You can actually analyze which tables are being used so often and which tables are not used at all, and then you can start moving data around with the hot and cold strategy. Means that some table is used every single day so many times, and it's in Hive and it's not performing really well. Then move this table to Teradata, and Presto will hide this change. So the customer, the only thing they will notice is that suddenly their view that yesterday was really slow, today is really fast. That's it. Or the other way around. One table in Teradata which is really big and nobody used ever, just move it to Presto, to Hive, to the big data space, and that's it. And then Presto will anyways show the same table. You don't have to really worry there about the from where is coming the data. That's why I like Presto so much. And yeah, and that's this unique point of absorb data from the data lake. So people doesn't need to maintain and work with so many different interfaces. Now it's going to be only one, which is Presto. You don't have to worry about Teradata, or if it's SQL Server or MySQL or Hive. Okay, just connect to Presto and that's it. So if you have less interfaces, less spaghetti diagram, and much better. So okay, what's next? How much would cost this? Okay, easy. I really think the most difficult part, at least for me, would be this auto discovery and auto ingestion into Hadoop from MySQL, SQL Server, Oracle, whatever, into Hive. this is the technologies used on each artifact. Here would be whatever source, and then HDFS, Python, Hive. This I estimate around 80 days, but there is some disclaimers here that depending on each company, their maturity on their big data cluster, etc. So depending, but let's say 80 days. Okay, maybe 2 people, 40 days, but whatever. The thing is that HDFS files into a historized Hive table, this could cost maybe 6 days, not more, for me at least, because I did it so many times already. I did it in Teradata, in SQL Server, and in Hive. Okay, last one in Hive using Python, and I would say only 6 days, and then you have your full snapshot, your whatever you have there. It will do deltas, and it will actually copy and prepare the table with the start and end date and with the history. Only one snapshot, let's say, with all the history. You won't have 365 times the same table with some little difference on each copy around. We have only one copy with the history. Then Datable framework, 10 days. This is my estimation. I can do it even less. Maybe people will do it in 20, but it's not so hard. Okay. Virtual March out of Data Vault. I say 15 days, but all depends. Yeah, it's a guesstimate. Okay, but what I'm saying here is that to accomplish this, if you know how to do it, it's not gonna be like a team of 10 people during 1 year. It's not. Okay, this could be done really fast. I did it so many times already, and it's really not that hard. Like this, you have the virtual marts already created here, and then do materialization every day. Drop and create, and blah blah blah. 2 days. It's not no-brainer there. Security framework, let's say 10 days. You know, data virtualization. This is something that I put here a lot of another disclaimer, because it's how to install Presto and do the admin and do all that. It's really out of this scope here. Okay, here I'm just saying 5 days to integrate all that with Presto, all this code, but not talking about how to install Presto, how to admin, how to maintain Presto. It's a technology that you need to install by your own, and it's not part of all this. Okay, I just say that it's good to have it, and it won't cost very little to just adapt the framework to use Presto as well. Okay, so that's it from me. Stay Jobs, stay hungry, stay foolish. I always think there is room for improvement, and we should try to point really high always. And please, if you have any question, just please let me know. I have here my my own blog. I have my email and my current number. I have if you need any consultation, please let me know. I have actually already talked to a few other companies that they saw me in some other videos. I'm working a bit in Bangladesh, in Australia, in Switzerland, but anytime, just send me an email and I can actually help you there. First thought in a big data era. So yeah, sorry for the joke. I also want to mention that I prepare, I have already, but I'm still finalizing some things. A Data Vault course. I will publish it soon. I will put somewhere here the links. I will put it also in the description whenever it's available. And please have a look and use the coupon if there is any, and that's it. So thank you very much for your time, and hopefully see you soon. Okay, bye.